Hey guys, so in these few set of videos, we are trying to understand the art of the state creation, that is dynamic programming. And in this particular video, we are trying to understand a very standard dynamic programming problem, that is the longest increasing subsequence problem. All right. So in the problem, you are given an array of length n, and you have to find the length of the longest increasing subsequence for this array. All right. So if we have a look at the first example, the array is 615 over here. All right, and the length of the longest increasing subsequence is equals to 2 for this case. Why? Because the increasing subsequences for this array are 6, 1, 5 and 1 comma 5. All right, so these are the increasing subsequences over here, and among them the longest one is 1 comma 5, so the answer is equals to 2. All right, so if we have a look at the second test case, the array is 4, 3, 2, 1, and the increasing subsequences for the second array over here is nothing but 4, 3, 2, 1, and among all of these the longest one is either of these, that so all of them have a length of 1, so the answer is equals to 1. All right, so for those who do not really know what a subsequence is, a subsequence is nothing but an ordered subset of an array. All right, so if you guys do not know that, you might want to google it out. All right, and an increasing subsequence is just a subsequence that is sorted in increasing order. So for those who do not know what an increasing subsequence is, you can google that out as well, and you will easily find that up. All right, so for those who understand the problem, let's see how we can code this entire thing up. So since this is a DP problem, we are going to take a tabulative approach in this particular video, and in the next video we will try to solve the same problem using memoization as well. All right, so for this video we are going to take the tabulation as the approach. All right, so let's just create a function lis, a very typical name for the function that computes the lis. All right, and it also takes in an integer array as parameter, and it tries to compute the value of the longest increasing subsequence. All right, so just for convenience, I'm going to create another variable over here that stores the size of this array. All right, now to solve any dynamic programming problem, in my previous video I had discussed, I split it into three different sub problems. All right, so the sub problem one is laying down the definition of the states of the DP. So I'm going to define DP of I linearly, that is DP of I is nothing but the length of the longest increasing subsequence starting from index I. So it's nothing but the length of the lis starting from index I. All right, now I'm going to lay down the second sub problem, that is finding the correct recurrence relation. All right, so DP of I is nothing but DP of I is nothing but, how do we actually, so it's a recurrence relation that helps us in computing the value of DP of I. So how am I going to compute the value of DP of I? So it's nothing but 1 plus max of DP of j for all j's such that j is greater than I and j is less than n, and the third criteria is arr j is greater than arr I. All right, so basically this is the recurrence relation that we are going to follow to compute the value of DP of I. And why is this recurrence relation correct? If you want to figure this out, I had uploaded a video on longest increasing subsequence as well, so that contains the entire theory explained deeply, so you might want to check that out if you are not able to understand it over here. All right, so moving on ahead, the third sub problem is laying down the correct topological order in which we can solve the states of the DP. So it's nothing but n minus 1, n minus 2, n minus 3, n minus 4, and up to 0th state. All right, so why is this the correct topological order? So for that, what you need to do is you should have a look at the recurrence relation. All right, so you have, what you need to observe is, to if you want to compute the value of DP of I, you should ideally know the value of all the value of DP of j such that j is greater than I. All right, you should know the values of DP of j that says that j is greater than I, because DP of I depends on these j's. All right, so that's why we should the correct order in which you should compute the states of the DP is n minus 1, n minus 2, n minus 3, n minus 4, and up to 0th state. All right, now that we have laid down the three sub problems and we also have the solution for these three sub problems, let's see how we can actually use these sub problems to code this thing up. All right, so since we are tabulating, we would want an array of size n over here All right, so we have array of size n over here that represents the states of the DP, and we are going to iterate over the states in this topological order we laid down in third subproblem. All right, so for int I equals to n minus 1, I greater than equals to 0, I greater than equals to 0, and I minus minus, what I will do is, the first thing that I will do is I'm going to initialize dp of I as nothing but 1. Why? Because the length of the longest increasing subsequence has to be at least 1. Alright, so I will initialize dp of I as 1. The next thing which I will do is I'm going to iterate over all the j's that are greater than y. Alright, so I'm going to iterate from j equals to I plus 1, j less than n, j plus plus, and for all such j's I'm going to consider the values of I'm going to consider the index j's with arr j greater than arr I. Alright, so this is the criteria over here, and if this criteria matches, I'm going to update dp of I as nothing but maximum of dp of I comma 1 plus dp of j. Alright, so this is another way to actually represent this recurrence relation over here that we laid down in here. So this is the same recurrence relation that we have actually coded up over here. Alright, so now that you know, now since this, if you this entire loop over here on line number 25, it's going to actually help us compute the value of each of these states. Alright, so what we want is the length of the longest increasing subsequence that can start from any index I. Alright, so if you notice from the definition, dp of I provides the length of the longest increasing subsequence starting from index I, and since we want the length of the longest increasing subsequence starting from any of the indices I will have to take the maximum of all of these states. Alright, so to do that, let's just have another another variable over here, that is answer, and for at the end of computation of each state, I'm going to update answer as nothing but answer equals to max of answer comma dp of I, and then I'm going to return this answer over here, that is the computed LIS. So this is the function that takes in an array as an input, and it computes the value of LIS using tabulation. Alright, so let's just try this function out with some few test cases. Alright, so let's just take in the test cases as an input first. So the first thing which I will take in as an input is the size of the array. The second thing is nothing but the array itself, vector int arr n over here, and then I'm going to iterate over all of these i's from 0 to n, and then I'm going to take arr I as input. And now that we have the size of the array and the array itself as an input, all I need to do is I need to call this LIS function up with while passing this array as a parameter into it. Alright, so this is the code that we wrote to actually compute the value of longest increasing subsequence for an array, and let's just try it out now. Let's see if this works or not. Alright, so if you notice over here, so this is the value of test case 0 over here. So if you notice, the test case was 5, that is the size of the array, and the array was 1 2 3 4 5, and for this we got the answer as 5, that is the correct answer. And for the second test case, if you notice, the array is 4 3 2 1, so we got the answer as 1 for the second test case, that is also correct. For the third test case, the array is 1 4 2 3 4 5, so the longest increasing subsequence in this case will be 1 2 3 4 5, so the answer will be equals to 5, and we got that as an answer, so this is correct as well. And the last test case is an array of size 1, that is 10, and the answer for this is equals to 1. So for all the sample test cases, we got the correct answer. And anyways, let's just assume that this entire code is correct because this is correct. Now that's how we actually code up the longest increasing subsequence problem using tabulation. Now coming to the runtime complexity of this problem. So the runtime complexity for this problem, that is time complexity, is nothing but O of n over here. Alright, so the time not O of n, O of n square over here. Why? Because if you have a look at it, look at this code over here. Alright, so So the total number of states is O of n, all right, and each state takes O of n time on an average to compute it. So the total time complexity becomes O of n square, and that's also pretty much understood from this loop over here. We are creating a nested loop, and the because of that, each loop on an average it takes O of n time to compute. All right, so this entire code over here, it runs on O of n time on an average. So if we try to understand via that, from that, the time complexity is O of n square again. So the space complexity is nothing but O of n. And that's all for this video, guys. I hope that you guys got to learn a lot from this video, and in the coming video we'll try to solve this exact same problem using let's say memoization, because in this video we took tabulation as the approach, and then consecutively we'll try to solve a lot of standard problems. So thank you guys for watching the video, and I hope to see you guys in the next video.